Okay, radians in the unit circle. Now I do have an activity we were going to do that we would be doing today, except I don't have the materials that I need to do it today. We're going to do it next week sometime. It's fine. So radians in unit circle. We're going to be talking about angles. And our angle measurements are not going to be in degrees. We're going to get away from degree measurements. Okay? Now, first of all, when we're talking about angles, and we're talking about it from the unit circle standpoint, which is what we're going to be dealing with here. Angles have two parts. They have the terminal side, the side where it ends. Terminal, ending, right? Okay? And we have the initial side, the starting position, where the angle begins, where the angle ends. Okay? For example, if I have an angle here going like that, and this is what we do in trigonometry when we're doing this, and what we're going to be talking about, measuring angles and such, and a lot of the things we're going to do here. We're not talking about angles with triangles. Okay? We're talking about angles with the unit circle. The initial side is always that one. This is always the initial side here. Always the initial side. The terminal side is the one that comes around there. And we always go in a counterclockwise direction to get to our terminal side. And that's where we measure our angles. When you're doing geometry, your angles are always somewhere between 0 and 180 degrees. We can have angles of any size. You can have 1,000 degree angles. You can have angles that measure negatively. We'll get into that. Okay? Now, the standard positions. An angle's initial side is on the positive x-axis. This is the standard position of an angle. Okay, just like I had there. Always starts on the x-axis, the positive one, going out from 0. That's it. That's our initial side. Okay, if that's our initial side, that means the angle is in standard position. And we use standard position basically for everything. Coterminal angles. Angles that overlap with different rotations. In other words, I have technically an infinite number of angles that will give me my angle that I have here. Coterminal angles will end at the same place. Okay. One possibility for a coterminal angle is if instead of measuring the normal way, which is this is what we would consider our positive direction. If we go in the other direction, and I draw this angle here, that would be a negative angle measurement. When you go clockwise, you get a negative angle measurement. Those are coterminal angles because they share an ending together. Okay, their initial side and the terminal side are the same. Those are coterminal angles. They're not the same measurement, but they are coterminal angles. Okay, they're not the same measurement. I could also do this. And measure it that way. And draw an angle where this is the initial side and that's the terminal side. And that is also a coterminal angle. I can go around more than once. I can go round and round and round and round and round as many times as I want. And I can go round and round and round in the other direction as many times as I want. So technically, there is an infinite number of coterminal angles. That would get very, very, very confusing. So we generally limit, when we're talking about angles in particular, we generally limit our range from 0 to 2 pi, which is the same as 0 to 360. We'll get to that in a minute. Okay. Okay. Radian. Angle whose terminal side sweeps an arc of length r. So here's where you think about it as far as what radian measurement is. To understand radian measurement, because we're going to use an awful lot of radian measurements. Okay? You have an angle like that. Okay? If this is the distance r, the distance from the end from here to here, you can imagine that there's a circle going around. Oh, it's a crappy circle, but deal with it. It's a little lopsided, more like a V. Okay. Radian measurement is how many r's, what this distance here is, that matches this angle there. How much of a radius goes around? How much of that radius is covered in that arc? That is our radian measurement. The angle measurement is how many radiuses we go around. So if I go 1 radius, then my angle measurement is 1. If that arc cuts off 1 radius, how much of this distance here, measures that angle there? How many r's, how many radii gives you that angle measurement? So if my arc length is 1 radius long, then the angle measurement is 1 radius, it's 1. Okay, and we're going to be dealing with radians in here, not degrees. We're going to start making that switch from degrees to radians. Okay, we are mathematicians. Mathematicians use radians. Engineers use degrees. In this classroom, we are mathematicians. We may do work to explain things to engineers, but we are mathematicians. Okay? In your physics class, you use degrees. In your mathematics class, you use radians. When you are taking tests, make sure your calculator is in the correct mode. Because if you have your calculator in degrees and you do it, everything, my questions are all in radians, you will come up with so many bad answers. Okay? And vice versa. If you go from this class to physics and you haven't changed your mode back to degrees, you need to understand that. You'll have something you're going to want to pay attention to. I'm just giving you a heads up now. I will try to remind you of that when we come to test taking. Just check your mode. Check your mode. I'll do that. I'll try to remind you that. Okay. The unit circle. The unit circle will become your friend. The unit circle will be one of the most important things that you will need to know. Almost everything with trigonometry that you need to know can be found within the unit circle. We are going to spend time today going over the unit circle. You will most likely have a quiz that is fill in the unit circle. Okay? I do not have it on the schedule, but I think I will add it to what we are doing at some point. Okay? The unit circle is a circle with a radius of 1. A unit, right? 1 is a unit. That's why it's called a unit circle, because the radius is 1. Our values of trigonometry, our values of our angle measurements come from sine and cosine measurements, come from the unit circle. And you'll see why when we're coming up on that. Okay? To convert from radians to degrees, and we are going to go back and forth from degrees to radians and radians to degrees. You're going to need to be able to do that. Once again, almost everything we will do in here will be in radians, not degrees, but so be it. To convert from radians to degrees, you take your degree measurement, multiply it by 180 over pi. To convert from degrees to radians, you multiply it by pi over 180. Okay. Notice your radian measurements are given in fractions. Your radian measurements are almost never decimals. It is extremely rare that your radians are in decimals. They will be in terms of pi's, and they will be fractional values of pi. Fractional or integer values of pi. You will almost never have decimal radians. You will not use 3.1415926 as an approximation for pi except in application purposes. You are going to use the exact value of pi, which is pi, for almost everything. Okay, and we're going to practice converting from degrees to radians because it's actually not that hard to do right now. But we look at the first one. I have pi over 10. That's an exact value. If I write that as negative 0.31415926, that is an approximation. We want exact values in here because we're mathematicians and we are exact as possible. Engineers are approximate. Close enough for government work. My dad used to say that all the time. Close enough for government work. Which really, when I found out that he was actually working for the government, made it even funnier. Okay. So this one really isn't all that difficult to do here. Convert from radians to degrees. What do? You multiply it by 180 over pi. Not a big deal. The pi's cancel, the 80 and the 10 reduce, and you get negative 18 degrees. So pi over 10, negative pi over 10 is negative 18 degrees. 2 pi over 5 times 180 over pi. The pi's cancel each other out, and you reduce it down. And this is 72 degrees. Pretty easy to do, right? Converting from degrees to radians. This is a little more difficult. It's not the multiplying that you're doing, it's how you're doing it. You multiply by pi over 180. You do not take 75 and divide it by 180. You do not come up with a decimal of pi. You come up with a fractional version of pi. You reduce 75 over 180. You take that fraction, 75 over 180, and reduce it. Your calculators generally do that. If you type in 75 over 180 as a fraction, your calculator generally will reduces your fraction automatically for you. Yeah, what do you get? You get 5 pi over 12, and that's how you say that. That's 5 pi over 12. Okay. So I do the same thing here. I multiply this by pi over 180. And then, like I said, put that in your calculator. 165 over 180 is a fraction. It will reduce it down. And you get negative 11 pi over 12. And that's how you say it, 11 pi over 12. Okie doke. Not too bad, really. Okay. Questions on those first two? They're pretty easy. Now it gets a little bit more difficult, and it's not so much that it's hard, but you kind of have to understand what's going on. Okay? Coterminal angles. What I'm looking for is I'm looking for the angle. So if I were to do this, this angle here, negative pi over 3, is right about here. That's the angle, negative pi over 3. That's about where it is. Okay. Here's what we want to do when we're looking for this coterminal angle. What we're looking for is, what is this angle measurement here? Starting here at their standard position, going in the standard positive direction, what is the coterminal angle that gives us that same place? That's what we're looking for. And it says between 0 and 2 pi because A zero angle, well, if we start here and have a zero angle, that's where zero is. And if we go all the way around, what is the circumference of a circle with a radius of 1? 2 pi. So 0 and 2 pi are in the same place. Okay, so that's what we want to do. Everything we want to have. We like to have our angles between 0 and 2 pi. That's kind of where we like to have our measurements. Is it possible to have angles that are not that measuring? Yes, but then we can change them to ones between 0 and 2 pi. And it's actually really pretty easy to do. You are either going to add or subtract 2 pi one or more times as needed to get your angle in that range. Okay, so if I want to think about it with this one, I have this negative angle measurement going down here. What I want to do is I want to find out what this one here is. If I were to go all the way around, that would give me 2 pi and then back up here. So this is what I do. I take negative pi over 3 and I add 2 pi to that value. That's what you're doing. And it's fractions, I know. It's 2 minus 1/3. Okay, we do not put these as mixed numbers. You never, ever, 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 ever have radians that are fractional measurements as mixed numbers. They're always improper because 2 minus 1/3 is 1 2/3. We do not do 1 2/3 pi. Okay, we make that 5 pi. Sorry, 5 pi over 3. And that's what the coterminal is. This angle measurement from here going around, that's 5 pi over 3. So negative pi over 3 and 5 pi, yeah, that's a horrible looking one. Negative pi over 3 and 5 pi over 3 are coterminal angles. And 5 pi over 3 is between 0 and 2 pi. That's where we like to have our range. Not our domain, our range. We want our range between there. Yes.
So you said you got 5 pi because it's negative 2 pi and 2 pi?
No, I want my answer between 0 and 2 pi. This is what I was given. I'm finding the coterminal one. I added 2 pi because I have a negative value here. I add 2 pi. Because I have a negative value, you basically add 2 pi to get it to the point where it's between 0 and 2 pi. You add as many of those as you need, depending upon where you're at. Okay? And so my answer is between this range. That's where I want my answer to be, between those two numbers. And once again, you never have mixed fractions of pi. You always have improper ones. It's not a whole number. You have it as an improper fraction. Okay? So the next one, is that more or less? Is 19 pi over 4 between 0 and 2 pi? No, it's in fourths. So that would need to be between 0 and 8 pi over 4, right? Because 8 over 4 gives me 2. 19 is more than 8. So I need to reduce that one because it's actually going around several times. What's happening with this one here? Okay. Is I start here and I go around a bunch of times until I get some angle, and I don't know if that's exactly where that angle will lie. Just kind of guessing, but it goes around more than once. So what I do is I take 19 pi over 4 and I subtract 2 pi, and I subtract 2 pi, and I subtract 2 pi until I end up with a number that's between 0 and 2 pi. So my numerator needs to be between 0 and 8. So if I subtract 2 pi, if I take 19 pi over 4 and I subtract 2 pi, and if I subtract 2 pi from that, 2 pi is 8 over 4, right? 19 minus 8 would give me what? It would give me 11 pi over 4. Is that between 0 and 2 pi? No. Because the numerator is more than twice the denominator, it's more than 2. So what do I need to do? I need to subtract 2 pi again. Okay, and if I do that again, so that would be 11 minus 8, right? 11 fourths minus 8 fourths. That would give me 3 pi over 4, and 3/4 is somewhere between 1 and 2. I mean, between 0 and 2. Okay, so that is where I'm at. That's my control. Okay. Yes?
Wait, so how do we know that it's like 8?
8 over 4. What's 8 over 4?
8 over 4. 8 plus 2.
See the connection? 2 pi, 8 pi over 4.
Okay.
Okay, yeah. Now, this one's decimal. Okay, so decimal approximation. We don't like to do that, but how are we doing it? Yes.
I'm kind of based off Noah's question. You know, with 2, how come it would be 4 pi over 2? How come it's 8 pi over 4?
Because what's my denominator on the first one?
Oh, shoot. Yeah, okay.
So it's like you have to make it.
I want to make it the same denominator.
Oh, yeah, just put it.
That's all, just common denominator for that. Because I did it over 3, so this one would be over 3. Okay, so the decimal one, it's a little bit harder. Kind of. Normally we don't do decimals. Now what is approximately the value of pi? 3.14, right? So what is 2 pi? 6.28. You should know 6.28. You should be able to be in your head, oh, 2 pi, that's 6.28. Start making that connection in your head. There are certain numeric values you need to be comfortable and somewhat familiar with. Okay, granted, a lot of these things took me a long time to memorize. Some of them they didn't, but you will eventually, there are certain values you will get down. So 6.28 is my decimal approximation. So I need to add 6.28 repeatedly to negative 15.2 until I get to be more than, until I get some number between 0 and 6.28. Because 2 pi, because we're doing it in terms of decimals, instead of doing 0 and 2 pi, it's 6.28. So if I add 6.28, that's not going to be enough, right? Because it's still going to be negative. So if I add another 6.28, that's still not going to be enough because that's what, 12 something? That'll still be a negative value. Negative 15 plus 12 is still going to be a negative value. We want to get it to be a positive value. So that means I need to add 6.28 one more time. And if you do that, you will end up getting 3.65. Now, we really, really rarely do decimals when we're talking about radians, but it does happen. Yes. Because what is 6.28? It's 2 pi. Is it? Yeah. That's negative 15.2. No, it's in radians because it's, yeah, it's state for radians. Right. And so, good question that came up. So why do we not know that 15.2 is in radians and not degrees? Okay, does it have a little degree sign on it? Then it's not degrees, it's radians. We're talking about angle measurements, and if it had a degree sign on it, we know we'd have degrees, and then we would do it with degrees in this case, in which case we would be adding 365.
Is there like a symbol for like radians?
No, there isn't. Yeah, you just know that they're radians. It's given in radians. What's the angle measurement? If it has a number with a little degree sign, it's in degrees. If it does have something else, it's radians. Okay, and you don't really see radians as decimals very often. You really don't. Okay, special right triangles. When I teach geometry, I hammer special right triangles because I know this day will come. All of your important trigonometric values will come from these special right triangles. And you will see that connection in just a little bit. I am not kidding. all of your special values for your trigonometric functions, the ones that you will need to know, the ones you will have committed to memory, all derive from the special right triangles. Okay? So the relationships of the sides of your special right triangles. If this side length is x, this side length is 2x, this one is x root 3. Right? The ratios between the sides. On 45, 45, 91s, x root 2. Okay? Now, for example, let's say we're looking at the sine of, actually, let's do this one. We'll do the cosine of 30 degrees. Cosine of 30 degrees. Do you remember the ratio of your right triangle ratios to the cosine?
Yeah.
We're talking about this angle here, and it is the opposite over the hypotenuse.
Oh, that.
So that would be x over 2x.
Wait, I thought
Okay.
cosine.
You're right. My bad. Let's change this. We want to make our life easier. We're going to make this the sine of 30 degrees, thank you. Which is the opposite over the adjacent. My bad. Change it to the sine of the cosine. It'll work out better because I like doing the math on this one easier. Okay. X over 2x. Huh. What does that reduce down to? 1/2. So the sine of 30 degrees is 1/2. It's always 1/2, irregardless of the triangle size. Does not matter because the ratios are always the same in a 30, 60, 90 right triangle, right? Doesn't matter how big it is. If this is 10, this is 20. If this is 30, this is 60. If this is 1, this is 2. It doesn't matter. The ratios are always the same. The hypotenuse is always twice as long as the shorter side in any 30, 60, 90 right triangle. So the sine of 30 degrees is always 1/2. The same thing for the cosine, the same thing for the tangent. And the same thing goes for the 45, 45, 90 right triangle. For example, if we were looking at the tangent of 45 degrees. Doesn't matter which 45 degree angle I pick. No, it doesn't matter. What is that tangent? It would be x over x, which would be 1. So the sine of 30 degrees is 1/2. The tangent of 45 degrees is 1. Using your right triangle trigonometry, remember, and it doesn't matter how long these sides are, the ratios are always the same. We can come up with these standard angle measurements. So for 0, we get those. Because if my angle measurement is 0, okay, and we'll see this more when I talk about the unit circle. The sine of 0 is 0, the cosine of 0 is 1, the tangent of 0 is 0. 30 degree angles. And 30 degree angle is equal to a pi over 6. In radian measurements, 30 degrees in radians is pi over 6. Pi over 6 in degrees is 30. These are ones you're going to need to know. All of the ones for zeros and ones, we'll talk about this in a minute. But pi over 6, pi over 4, pi over 3 are huge. Okay? For pi over 6, the cosine is root 3 over 2. And the tangent is root 3 over 3. For 45 degrees, for pi over 4, root 2 over 2. Cosine is also root 2 over 2. Sine and cosine are the same angle measurements. Root 2 over 2. Pi over 3 is root 3 over 2. Interesting. 1/2 for the cosine. And root 3 for the tangents. We'll talk about these in a little more detail. And we're going to come up with some more of this stuff as we go along. Okay. 90 degrees. Now, the sine and cosine values, not for the first ones, not for the end, but all the ones in the middle all come from these two triangles. The tangent measurements come from the fact that the tangent is the sine over the cosine, or you can use those angle measurements there and figure them out the same way. These values are by far and away the most important values of sine and cosine that you absolutely need to know. Okay? You need to commit them to memory. Notice there's a pattern though. Look at the sine values. They're all over 2. 1, root 2, root 3. What is it? How can I write 1 as the square root of something? 1 is the square root of what? 1. Square root of 1, square root of 2, square root of 3, all over 2. Oh, look at the cosine. Square root of 3, square root of 2, square root of 1. It's counting down as you go across. Imagine that. So can I write 0 as something over 2?
Yeah.
0 over 2. Can I write 1 as something over 2? 2 over 2, which is 2 is the square root of 4. There's a pattern. It's all about patterns. Square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. Okay, and the cosine works in the exact opposite direction. Okay. These values that are in this table, you need to have committed to memory. However, there is a better way to understand them and to memorize them and to apply them to what you need to know. Okay. This is the unit circle. This is, oh, don't worry, it's going to get better than this. This is the degree measurements, or I should say the angle measurements in the unit circle. Okay, this is not the values that you need to have memorized. But what this does is this relates the relationships between the angle measurements in degrees and the angle measurements in terms of pi and radians. Degrees are on the outside, radians are on the inside. You need to have these values understood. Now, almost everything we're going to do is going to be in radians. There is another one I want to add to this. 2 pi, this is also 0 degrees. If we start with an angle, can you have in geometry an angle that measures 0 degrees? No, because if you're making a figure, because geometry deals with actual objects, you cannot have an angle measurement of 0. However, in trigonometry, we can have an angle measurement of 0. We can have an angle measurement of any freaking size we want, positive or negative in trigonometry. An angle measurement of 0 is one where the initial side and the terminal side have the same side. That's a 0 degree measurement. Okay. Now, this is not in your notes. However, I do have a hand up to go with this. The unit circle.
Is it like a whole unit circle, or is it just a half?
Oh, I'm going to give you the whole one, but we're going to talk about the first quadrant.
from bio. If we had a unit circle class here, we're like,
Yeah, unit circle, unit circle, unit circle.
we got this goal. No, he's
Okay,
I enjoy
so I only have up here the first quadrant. I only have up here the first quadrant of the unit circle, because the first quadrant is probably the most important one to deal with, because if you know and have the first quadrant memorized, you can do the rest of them. If you have the first quadrant memorized, all the rest of the values of the unit circle will fall into place very easily. Now, the first thing is I am going to ignore, for my purposes here, the degree measurements. I'm going to stick with the measurements in terms of pi. And this is, once again, the first quadrant, and it does count counterclockwise, 1, 2, 3, 4, because that's the same way the quadrants count in the Cartesian plane. Okay, this is 0 radians and 2 pi radians as well. Okay. And then from here it counts up, getting larger. This is pi over 6. This is pi over 4. This is pi over 3. And this is pi over 2. That's my first quadrant. Okay. Here's the thing. This is, you can lay this over the Cartesian plane. This is from the unit circle, which means the radius is 1, right? So if I were to lay this on the units, on the quadrant plane, if I have a radius of 1, what is the coordinate here? What is the x-coordinate for there? This is the origin. This is the point on the outside, on the first edge, on the x-axis. What is the point? It's 1, 0. X is 1, y is 0. This is 1, 0. Where is this coordinate here? 0, 1. Okay, for unit circles, that's what you get. Now, here's a really cool thing about unit circles. The xy coordinates. The xy coordinates going around the unit circle are the cosine and the sine for those angle measurements. So at 0 degrees or 2 pi degrees, or sorry, 2 pi 0 radians or 2 pi radians, my cosine is 1, my sine is 0. At pi over 2, my cosine is 0, my sine is 1. Now I have to fill in the rest. This actually is a lot easier to do than you think it is. Remember back the table I just showed you? What was the denominator for every single fraction for the sine and the cosine? It was 2. So these are all something over 2. 2. And now I have to figure out whether it's 1 or 2 or 3. Square root of 1, which is 1, or root 2 or root 3. 1 or root 2 or root 3. Well, the pi over 4s are the easy ones. These are the ones I always remember. Right off the top of my head, I don't have to think. Those are always root 2. Sine and cosine, pi over 4, root 2 over 2. Now I have to stop and think. Is the cosine, is this coordinate here 1/2 and root 3 over 2, or is it root 3 over 2 and 1/2? This is the one where I have to stop and think. Okay, but once I get it, everything else clicks into place. Here's how I think about that. I go, all right, let's see, if I had this as a triangle, that would be my 30, 60, 90 right triangle. Which distance is longer, the x-coordinate or the y-coordinate? The x-coordinate's longer. So the x-coordinate would be my root 3. The y-coordinate would be my root 1. This is root 3. This is my 1. And I go 1, root 2, root 3, and 1, root 2, root 3. That's really honestly how my brain works when I have to stop and think about it, because you do have to stop and think about it. You are expected to know by heart those values of sine and cosine for those angle measurements in degree, in radians. You need to have them committed to memory, not just for here, but for everything that follows. You are expected to know those values. If I ask you for the sine of pi over 4, you need to be able to spit out root 2 over 2. Okay? You're expected to know those values. I will give you a quiz at some point on these values. Now, here's a really cool thing. If you get this first quadrant, come on, over. There you go. The rest of it's a piece of cake to fill in. Absolutely, positively, the rest of it's a piece of cake to fill in. Okay? These 4 points going around are really easy. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Yeah. Because when I'm going around a unit circle, you know, radius of 1, those are the easy ones to get. Now, we had, this was root 3 over 2, sorry. Root 3 over 2, 1 over 2. Root 2 over 2, root 2 over 2, 1 over 2, root 3 over 2. Now, here's a really cool thing. Every quadrant is a reflection of that quadrant. With the signs positive or negative. With the signs changed positive or negative. Every one of them is. In this quadrant here, my x's are negative, my y's are positive. So if I take all of these values and flip it over here, this will be negative root 3 over 2, 1/2. Negative root 2 over 2, root 2 over 2, and this will be negative 1/2 root 3 over 2. It's a reflection. And the one below it is a reflection, with the x is positive and the y is negative. So this would be root 3 over 2, negative 1/2. Root 2 over 2, negative root 2 over 2. And this one would be 1/2 and negative root 3 over 2. It's nice. And what's true about the signs in this one? In this quadrant, they're both negative. Negative, 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 positive, 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 and positive, negative. Those are the signs for the x and y coordinates in those quadrants. So in this one, they're both negative, and you just fill them in the same way as reflections of this. Or of that one. It doesn't really matter. Okay. So I have negative 1/2, negative root 3 over 2, negative root 2 over 2, negative root 2 over 2, negative 1/2, negative root 3 over 2. Those are your sine and cosine values all around the unit circle. But do you see why I said if you memorize that first quadrant, you can fill in the rest of it, no problem? Okay. And to be honest, the first quadrant ones are the ones you really need to know more than anything else. If I tell you, and then you have to know your radians. The radians are easy to fill in. You already have those on the other one, but this is 0 or 2 pi. And we did this one was pi over 6, pi over 4, pi over 3, and this one was pi over 2. And then you can count the rest of the way around accordingly. Okay. I like to do my pi's and pi's over 2 going around. So if I count by that, I got 0, pi over 2, pi, and this is 1.5 pi, which would be 3 pi over 2. filling in my pi over 2s. Those are the big ones. Okay. My pi's over 4s are the next ones. This is 1/4 pi. This is 2/4 pi. This is 3 pi over 4, or 3/4 pi, right? 4/4, 5/4 pi, so 5 pi over 4. And I go around, and this would be 6 pi over 4, and this one would be 7 pi over 4. Counting my pi's over 4. Okay, does that make sense? You can do the same thing by counting by pi's over 3 when you do the pi over 3 ones. Pi over 3, 2 pi over 3, or 2/3 pi, 3/3 pi. This one down here would be 4/3 pi, or 4 pi over 3. And this one here would be 5/3 pi, or 5 pi over 3. And then 6 pi over 3, which is 2 pi. So you count around by that. And then the pi over 6s are easy to fill in from that standpoint, regularly speaking. Pi over 6 here, pi over 6, 2 pi over 6, 3 pi over 6, 5 pi over 6. Or sorry, no. This is 4 pi over, wait, pi over 6, yeah, you're counting around by pi's over 6s. You get to here, this one would be 1 pi over 6 less than 1, so this would be 5 pi over 6. This is 1, right, which would be 6 over 6. So the next one down would be 7 pi over 6. Counting around, this one is 2 pi, which is 12 over 6, right? 12/6 is 2. This is 1/6 less than that, or 11 pi over 6. Yes? No, 2/3 pi. This is 1/3 of a pi. This is 2/3. Yeah. Trust me, I know these ones inside and out. Okay. Now, to be perfectly honest with you, I did fill it in. If I were taking a quiz, I could fill it in. It'd take me about that long, and I'd have to stop and think about the places along the way. Once again, knowing that first quadrant will give you your sine and cosine values. You absolutely need to know your sine and cosine values for the 4, 1, 0, 2 pi, pi, 3 pi over 2, and 4 and 2 pi. The 4 ups and downs, the 0s and 1s and negative 1s, those are huge. That first quadrant, pi over 6, pi over 3, pi over 4. If you know those, you can get everything else. You may have to stop and figure out what you need, but you can get everything else. There is no need to memorize the entire unit circle. No need to memorize the entire thing. If you know that first quadrant, you can fill in the rest. Right? You see what I'm saying about that? You know that first quadrant, you can find the rest. You might be asked, what is the sine of 3 pi over 4? Well, if you know the sine of pi over 4, you can figure out the sine of 3 pi over 4 just pausing. Ooh, pi over 4 is here. 3 pi over 4 is this one. Ooh, the sine is going to be root 2 over 2. Is it negative or positive? Okay, my y value is positive. It's going to be root 2 over 2. The sine of 3 pi over 4 is root 2 over 2. That's what you're going to have to be able to do. You're going to have questions on your test where you're going to be given, you know, find the sine of this value, find the cosine of that value. You're going to need to know them. And you're going to need to know the exact value, not the decimal equivalents. And this is not just for me. This is the things that AP expects you to have memorized. And they really honestly only expect you to be able to figure out anything that's in here. And yes, it does seem like a lot, but once again, if you have that first quadrant down, the rest of it actually isn't that hard to deduce. It really isn't that hard to deduce if you have that first quadrant down. Okay, that is the most important thing. Get that first quadrant down. When you get that one down, you can deduce the rest of the values you need to be able to do. That's a big deal. You cannot. Once again, on the AP test, in here, in calculus next year, you are expected to have certain things committed to memory. Those values, particularly that first quadrant set of values, you absolutely need to have committed to memory. They will ask you questions that are non-calculator questions where you have to know what the sine of pi over 4 is. And to be able to put the answer out in terms of radicals. Ooh, that's root 2 over 2. You are expected to know those values. The 4 big ones, you know, the straight ups and straight outs in that first quadrant. If you got that, you've got the rest of it. Okay? And I will give you a test where I'll give you one of these blank, you'll have to fill it in. Okay, I'll give you a week or so before I have to do that. Okay, but we will definitely do it before we get to the chapter test. But I will have planned sometime in a week from now, maybe a little bit more. Probably the week after that. I'll hand this out. Blank one just like I gave you, and you have to be able to fill it in. I'll put a blank one on the website so you can download it if you want to do that. No, I'm not going to care about the degrees. I'm going to care about the radians. Because the degrees are easy to fill in, but well, honestly, we're not going to do a whole lot with degrees. And you need to know the radians a lot more than you do the degrees. Okay. Any questions? Okay. Come on, stop.
You start dashing before.
No, I
All whole side.
Come on.
What do you think?